There's been a lot of buzz lately about our next topic, as scientists and health experts now believe that epigenetics is offering us the chance to prevent diseases that we've often regarded as it runs in the family, so I'm bound to get it. To further shed some light on this revolutionary theory and the practicalities involved is Dr. Fariel Luha, a naturopathic doctor. She's joining us via Zoom all the way from Toronto, Canada. Dr. Fariel, thank you so much for joining us. I know it's quite early on that side of the world.
It is quite early, and I'm really glad to be on with you again after quite a few months and after everything that's been happening in the world. So thank you, Michael.
Absolutely, it's a great pleasure. Now, just let's get a bit of context here for the viewers. What exactly is epigenetics?
Epigenetics is a growing body of research. It's a growing body or field of study around how genetics interplays with various environmental factors. So the word epigenetics actually means above or just on top of the genes. So we know what the genes are, or the genome, right? This is our DNA. Epigenetics refers to everything that is in the environment of the genes, which will influence how the genes express themselves. So we're talking about things like diet, nutrition, nutrient availability, toxins, stress, how one sleeps, all those kinds of environmental and lifestyle factors.
Okay. Now, how do these epigenetic factors assist in preventing or reverting diseases that traditionally run in the family, so to speak?
So the, if I can say, old, way of thinking about genetics that most of us probably learned in school was that your DNA pretty much predicts how you're going to turn out. And this has been true for a very long time. And we've even heard the argument, nature versus nurture. However, now more and more in the last decade, I would say maybe the last 8 years or so, we are starting to find out that actually it's not nature versus nurture. It's actually both. They're very much involved in how the genes express themselves. So when we talk about epigenetics, we're not talking about changing the code of the genes. We're just talking about how the gene expresses itself, which means it's going to change the way that the gene functions, because every gene is coding to make something, whether it's a protein or an enzyme or a hormone or what have you, to help the body function well. So if we have epigenetic influences that can be negative, for example, if someone is smoking, or they've been through a lot of stress in their lives, or there are what we call alterations on the genes. We have certain things, mutations, which we call polymorphisms. If those mutations are on certain genes that are going to influence how that gene works, then this is going to impact health. So we're looking now, we have access to a tool where we can look at various genes that are related to how the body functions. And if we see these alterations, and if those alterations atop the DNA are influencing how the gene is going to work, then there are things we can do in terms of nutrition and lifestyle interventions to optimize the way the gene will express itself.
Okay. Now, Fariel, just as you're talking and explaining that, I'm getting a sort of a picture in my head, and if I just want to confirm if I'm on the right track here. So if you've got maybe you've got a map of a journey that you're going to take, and then there's certain influencing factors that knock you off course slightly and put you on a slightly different course. Is that kind of a fair enough metaphor for the process of epigenetics and the effects of it?
Yes, absolutely. You're 100% on the right track. So what we've discovered, or what scientists in this field are discovering more and more every day, is the fact that the way we live our lives and everything that we are putting into the body are going to create what we call little marks. They're going to be like little tags on top of this DNA, and that tag is going to imprint itself and change the trajectory of how that gene is going to work. Now, a lot of these epigenetic factors actually will silence certain genes that might cause activate certain genes that help you to become healthy. Obviously, we want to make sure that we're living in a way that activates the genes towards health and keeps the ones that might lead us towards disease neutralized or silenced. And so again, goes back to the fact that many of us have been told that if there's a strong family history, let's say of something like diabetes or heart disease or obesity even, that we are probably more than likely going to end up the same way. But now we're seeing that that's not so much the case. We can actually change the trajectory of how the blueprint, the DNA that we've inherited, how it actually manifests itself.
Okay. And Farrell, what are some of the most prominent influencing factors in epigenetics? You mentioned stress and smoking a little bit earlier in the conversation, but what are the ones that are showing up as having the biggest or the most consistent impact on our genes and the trajectory that they're going in?
Yeah, that's a great question. So when we talk about environmental influences, again, we're talking about the environment in which that gene resides. So primarily it's going to be nutrition. And when we talk about nutrition, about nutrients and different kinds of vitamins, minerals, amino acids, and so on that are building blocks that the body requires to make something that the body needs, whether it's a protein or a brain chemical or a part of your liver or a hormone. And so there are genes now that code for how we actually absorb some of these nutrients. If I can give you an example, there are genes that code for how magnesium will efficiently or inefficiently enter a cell in order to do its job. And as you know, magnesium is responsible for 300 to 400 different reactions in the body. It's so important. And about 90% of us are deficient in magnesium. So if you have an alteration on your gene, if you've got this mutation or SNP, the polymorphism, on top of the DNA, on the epigenetic side of the DNA, that's going to alter how you actually allow magnesium to enter the cell. It's the same thing with vitamin D. So a lot of us are deficient in vitamin D, and vitamin D is implicated in so many aspects of health, from cardiovascular health to mental emotional health. It's protective against cancer. Of course, it's implicated in bone health. And some of us may be taking, a lot of vitamin D, but when we check our blood levels, it's not reaching optimal levels. It's possible that this individual may have an alteration on the gene that is responsible for regulating and governing the absorption of vitamin D.
Okay. Now, if there have been alterations on the genes because of lifestyle factors or dietary challenges or whatever it might be, whatever the cause might have been, is there a way to reverse this through making changes in your lifestyle?
So this is the good news, right? Is that we now can look at the DNA that can be modified in terms of its epigenetic factors that can be influenced by now changing the environment in which that gene resides. So again, a metaphor that I really like to use with my patients, Michael, is if you think of the genetic code and the epigenetic factors being like a set of instructions. So if I could liken that to giving you a recipe to make chocolate cake, right? So that's the code, that's the set of instructions to make the cake, which will include all of the ingredients and how to mix them, whether it's the eggs or the flour or what have you. But let's say that instead of cocoa, I have mistakenly put chili powder. Right, that's the alteration on the gene, or like the epigenetic factor that's now saying instead of cocoa, it's chili powder. Are you going to end up with a cake? You'll end up with a cake, absolutely, but it's not going to look like a chocolate cake. And it's not going to taste like a chocolate cake if you love spicy cake. So what do? Now we know that if we can see some of these alterations, and it is linked to the fact that the environment is missing certain nutrients, there is an epigenetic mechanism called methylation that you might be familiar with, and some of your viewers. Methylation is so important because this is how the body fixes and repairs and heals the DNA, and DNA is undergoing wear and tear all the time. So if our methylation, epigenetics are not functioning well, if we have alterations for methylation, we're not able to repair DNA. That means we age faster. It means we're going to set ourselves up for chronic disease. And when it comes to methylation, there are certain nutrients that really help those genes, things like folate, vitamin B6, B12, magnesium. So that's one example of how you can kind of manipulate that interface between, the genetics and in nutrition and environmental influences. Okay. Also, we're learning more and more now that some of these epigenetic factors are actually transmitted across 1 or 2 generations. So if parents have had issues with their health, mental, emotional, or otherwise, depending on what's happening while the offspring is in utero, there can be changes on that offspring's DNA that can set them up for the same.
Interesting. So it's not just about the inherent genes, it's about the experience that you have in the womb as well.
But ultimately, now that we have access to doing these tests, I think it's a great idea for people to take advantage and get some of these panels done so that they can understand the blueprint that they inherited, 50% from mom and 50% from dad, to understand where the weaknesses may be. And then they can target those weaknesses with their practitioner in a holistic manner to ensure that they are moving the trajectory of whatever DNA blueprint they got towards health, not towards disease.
Well, thank you so much, Fariel. Always great to chat to you, and definitely a very interesting discussion around epigenetics.